Welcome to the course Open Source Software for Academia. Over the next few weeks, we'll explore 3 open source software and see how they can help us to develop our skills and expand our knowledge. Let us start by understanding what this course is all about. Throughout the course, we'll focus on 3 key open source software tools: Latex, Scientific Lab, and Python. These powerful tools are widely used in academia, and learning them will enhance our productivity and creativity. Latex is a document preparation software tool for high-quality typesetting. Scilab is a scientific software package for numerical computation, and Python is a versatile programming language used in various domains such as data analysis, web development, and machine learning, and more. We will discuss each of these open source software tools, covering their features, capabilities, and practical applications. So what exactly is open source software? We can say it is a software whose source code is designed to be publicly accessible for anyone to use, modify, and distribute. This means its creator makes the source code available for others to view, copy, learn from, and modify or share. Unlike proprietary software, which is owned and controlled by a single entity, open source software encourages collaboration and community-driven development. Let us provide a more detailed explanation of the differences between open source software and the proprietary software. Number 1, open source softwares are software with source code that is freely available for anyone to view, modify, and distribute. On the other hand, proprietary softwares are software with source code that is owned by an individual or organizations and is not available for public to view or modify. Generally, open source softwares are free to use, though some versions or services may have a cost. On the other hand, proprietary software typically requires the purchase of a license or subscription. Next is open source software are highly customizable. Users can modify the software to meet their specific needs. But in case of proprietary software, users cannot alter the software beyond what the developer allows. Open source software gets help from the community through forums, wikis, and guides shared by the user. For proprietary software, the company that makes the software usually provides the professional help, but we may need to pay extra for it. In case of open source software, security is reviewed by the community and errors can be quickly identified. But in proprietary software, software vendors retains ownership and control over the software. Open source software is shared under special licenses such as GNU, GPI, Apache licenses, etc. These licenses allows people to freely share, use, and make changes to the software. But proprietary licenses restrict copying, modification, and redistribution of the software. There are numerous examples of open source software across various domains. Some familiar examples are Linux operating system, Mozilla Firefox web browser, Apache web server, LibreOffice productivity suite, Latex, Python, etc. And some common examples of proprietary softwares are Microsoft Windows operating system, Mac OS, Microsoft Office, Adobe Photoshop, AutoCAD, etc. Learning open source software is important, especially in today's digital landscape. There are several key reasons. Some of them are transparency and security, cost effectiveness, customization and flexibility, community collaboration. Transparency and security indicates with access to the source code, user can verify the security of open source software and identify any potential vulnerabilities. This transparency leads to greater trust and security in software system. Another importance is cost effectiveness. Open source software is often available for free, eliminating the need for expensive licensing fees. This makes it particularly attractive for individuals and organizations with limited budget. Next is customization and flexibility. Since the source code is open, users have the freedom to modify and customize the software to suit their specific needs. And community collaboration is one of the importance of open source software. Developers from around the world contribute their expertise, leading to rapid innovation and continuous improvement of the software product. Today, we are starting with the first module of the course. The title of this module is Introduction to LaTeX, Basics and Installation. This module includes two lectures. Lecture 1 is Getting Started with LaTeX and Lecture 2 is LaTeX Installation and Compilation. Let us begin with the first lecture, Getting Started with LaTeX. Here we will provide an introduction to LaTeX. We will explore how LaTeX can benefit us, particularly when creating professional quality documents. We will also look at the advantages of using LaTeX compared to conventional word processors. Additionally, we will discuss the key differences between TeX and LaTeX, giving a clear understanding of their roles and how they work together. LaTeX is a document preparation tool and typesetting system. It is widely used for creating documents that require high quality formatting, particularly in academia and research. Learning LaTeX is particularly useful for creating complex documents like academic papers, thesis, dissertation, technical report, books and articles. In 1978, computer scientist Donald Kruth created a document preparation system called TeX, designed specifically for typesetting text and complex mathematical formulas. Later, mathematician and computer scientist Leslie Lamport built upon TeX to develop its improved variant known as LaTeX. Therefore, LaTeX can be considered as an extension of TeX. The name LaTeX is derived from Lamport text in recognition of the creator. Let us talk about how LaTeX differs from traditional word processors like Microsoft Word. Many of us are accustomed to use word processor like Microsoft Word for document preparation, but some others find comfort in using LibreOffice Writer for the same purpose. These applications allow effortless creation, editing and formatting text, simplifying the document preparation process. When you use a word processor like Microsoft Word, you can see the final appearance of your document as you type. It is a what you see in what you get approach. However, LaTeX works differently. LaTeX is a powerful markup language designed specifically for typesetting documents. Unlike word processor, it does not show us the final output while we are working on the document. Instead, we can focus on writing the content and adding markup commands to structure and style it. Once we process the LaTeX file, we can preview the output. This approach helps us concentrate on the content itself rather than being distracted by the formatting during the writing process. If we need to adjust the formatting, we will simply add or modify the markup commands in our source file. By separating content creation from formatting, LaTeX offers a more efficient and professional way to create well-structured documents. Since LaTeX is open source, its source code is accessible to everyone. This open source nature encourages collaboration and innovation, allowing users to tailor the software to their specific requirements. Now let us understand its foundation. LaTeX is built on top of TeX, which is low-level language that many find challenging to work with directly. To address this, LaTeX was developed as a user-friendly interface. It simplifies the process of creating structured and professional documents, especially those that involve complex elements like mathematical equations. Because of this, LaTeX has become a popular choice for writing technical and academic documents. TeX and LaTeX both are powerful tools for typesetting, but they have distinct characteristics and purposes. TeX is more suited for users who require precise control over typography. On the other hand, LaTeX is ideal for users who prefer a high-level interface with simplified document preparation. Now let us discuss how the LaTeX is useful. LaTeX offers several advantages. Number one, consistent formatting. That is, LaTeX takes care of the formatting for you, ensuring that your documents always look clean, consistent, and professional without the need for manual adjustment. Mathematical typesetting is one of the important features, as it is the ability to beautifully typeset mathematical equations and formulas. It is useful for students in the field of mathematics, physics, engineering, and more. LaTeX offers benefits for researchers and authors in creating scientific papers, articles, theses, books, and other professional documents. It is due to its high quality output, that is, LaTeX produces documents with exceptional typographical quality, which is crucial for academic publications and journal articles. Precision and control, that means it allows precise control over layouts, making it ideal for scientific documents that include complex elements like equations, tables, and figures. Next is standardization. Many journals and conferences provide ready-to-use LaTeX templates, ensuring submission adhere to the specific formatting guidelines effortlessly. Next is cross-referencing. LaTeX simplifies managing cross-references for sections, figures, and tables, improving document clarity and navigation. Next is automatic indexing. LaTeX automatically generates indexes, tables of content, and list of figures and tables, saving time and effort for users. Next is efficient bibliography management. With tools like BibTeX and BibLab LaTeX, researchers can easily organize, format, and update citation and references, saving time and effort. LaTeX integrates seamlessly with various academic tools and platforms such as reference managers like BibTeX, Zotero, scientific computing software such as MATLAB, Python, and presentation tools like Beamer. LaTeX also facilitates collaboration. LaTeX files can be shared and edited collaboratively, making it a practical choice for team projects and co-authored work. These features make LaTeX an indispensable tool for academic and professional writing, especially in research and scholarly publications. Let us talk about how LaTeX is useful for teachers and educators. For creating course material, teachers can use LaTeX to design well-organized and professional-looking course materials. Whether it is lecture notes, assignments, or exams, LaTeX ensures that the content is not just easy to read, but also visually appealing. LaTeX also offers ready-to-use templates. It offers variety of templates specifically tailored for educational purposes. These templates can save time and effort by providing pre-designed formats for documents, which can be easily customized to fit our teaching style or course requirements. Using LaTeX, we can enhance the presentation and delivery of educational content, making it more effective and engaging for students. Some examples of documents that will look more appealing when created with LaTeX include academic papers, research articles, books and reports, theses and dissertations, technical manuals, presentation slides, CV and resumes, question papers, etc. Let us talk about how to create a LaTeX document. To work with LaTeX, we require a text distribution which enables the compiling of .tex files to generate output files from the source. Output files are the form of PDF or DVI suitable for printing or digital distribution. We can create a LaTeX documents, that is the LaTeX source file, using a basic text editor like Notepad. However, it is much simpler to utilize a specialized LaTeX editor. We'll learn how to use LaTeX editors such as TextStudio or TextWorks while writing LaTeX code. Some examples of LaTeX editors are TextStudio, TextMaker, MikTeX, etc. Now I am going to summarize the lecture. In today's lecture, we covered the fundamentals of LaTeX, laying a solid foundation for its application in document preparation. We started by understanding what LaTeX is. LaTeX is not a word processor. Instead, it is a document preparation system. Using plain text files and markup commands, it allows you to focus on content while it handles the formatting for you. It is particularly popular in academic and scientific communities. We then compared LaTeX and TeX. LaTeX simplifies the document creation process with predefined styles and commands, making it more accessible and efficient. We also discussed the many benefits of using LaTeX, including its ability to automate complex tasks like creating bibliographies, formatting large documents, etc. Its scalability and precision set it apart from traditional word processors, especially when handling academic, technical, or lengthy documents. Additionally, we touch on the broader significance of open source software at the beginning of this lecture, emphasizing transparency, security, and cost effectiveness, and the flexibility to customize tools like LaTeX. These qualities make LaTeX not just a tool, but a valuable resource for anyone involved in producing high-quality document, whether for academic, professional, or personal use. With this understanding, you can now equipped to take the next step, installing LaTeX and starting to work hands-on with this powerful system. Some additional resources available online are provided here to enhance your understanding of LaTeX. First, we have the online LaTeX User's Guide. The link is provided here. This is a comprehensive manual provided by the LaTeX project, ideal for both beginners and advanced users. Next, you can explore the LaTeX Premier, and here is the link. This guide is concise and focuses on practical examples to help you get started quickly. For a beginner-friendly approach, check out the LaTeX Beginner's Guide available at this link. You can explore these resources to deepen your learning and practice using LaTeX effectively. In our next lecture, we'll focus on the practical aspects of getting started with LaTeX. This includes installing LaTeX on both Windows and Linux operating systems and setting up user-friendly editors like MikTeX and TextStudio. These tools are essential for creating and compiling LaTeX documents efficiently. Screenshots and step-by-step instructions will be provided to guide you through the process. By the end of the next session, you will have a fully functional LaTeX environment ready to use enabling you to dive into the creating your first documents. This foundation prepares you for deeper exploration into LaTeX in the upcoming lectures. Thank you.